So I wanted to do this spinning gravity calculation, but I don't think I ever could find the scale. Okay, so
So
I
this
was going to
is
use this video here and time the spinning of these spinnies to
okay.
get what artificial gravity might be in those containers and pods.
Oh,
But in
okay.
or,
You're saying
but
there
it,
are people in there and they're
yeah,
experiencing some type of gravity, but they're not on the planet,
mhm,
so they're getting this artificial gravity from the spinning of the space station or the
yeah,
transit ship. But you're not sure if they're like in here or they're in there. Is that what you're saying?
yeah. And I'm also not sure how to get scale from this. So
Okay.
like where's a meter? Where's a 10-meter object?
What's the
So what I
reference?
did, yeah, I went into where they were giving this briefing here, and I was like,
Okay.
maybe this is the interior. We can get some scale here. So let's take a look.
Okay. So these are
Okay,
Navi people. I mean, okay, the humans in the Navi bodies, and like
exactly.
here's a human person. So that's
Hmm.
like that's like a meter,
Hmm.
1.8 something
Yep.
meters, like a normal
Yeah.
human male type.
Yeah. And we're in this hexagonal structure. I was like, okay, I kind of
A
found a
hexagon.
hexagonal structure
Okay.
in the other picture. But so yeah, if you go back, yeah, right here. If you look at one of these cargo pods at the lower end, radially
Here.
away from the center,
Oh.
I
Oh,
you
this
can
here.
yeah, that kind of tube thing looks
I see
hexagonal
it.
to me.
Because okay. So you're saying if we were down there, the walls would
Hmm.
be rectangle, like a normal building, right?
Yeah.
What you're saying is here, a little bit hard to see, but
Hmm.
here's if this was square, then we'd have a square
Yeah.
room. But we see these like flat sides here,
Yep.
which means that the room is not square; it's curved on top,
Yep.
which is hexagony.
Right.
Okay,
So I was thinking that briefing from Quaritch's new body
over there.
is
Yeah.
happening in there. But
Uh-huh.
if you look in the background of this video, you see Parallax with a second room.
And
See that back
right there, right there. This room back here,
there. Yeah. Yeah.
back here. Okay, so there's
There's
a second room back there.
exactly. So
Okay.
which means we're not in an isolated hexagonal tube. There's actually adjoining tubes or adjoining
Oh,
somethings. We're not just hanging off the end of that.
so it
So
cannot be in here
I
because
don't think
there's like another room next to it.
yeah, there's another room next to it. Maybe
Mm,
you could argue there is maybe another room next to it if there's it's
yeah,
kind of held on by, but I wasn't sure.
true.
So I was like,
Oh, actually, okay. Wait, even if they were in here, and this is the room on the side, the effective gravitational field should be outward, right? So that
well,
means here they would be, if this is like the side, then they should be standing on the wall out here. Like the direction of gravity is the wrong way.
oh, yeah, I think it might be okay because now that I'm looking at it, so they're in the hexagonal structure, and we look through
Okay,
this opening here, and there's a second cargo area
over
back
there.
there.
Yeah.
Yeah, and if you look at the other picture,
Oh, so it's maybe there.
maybe that's the adjoining cargo, and I didn't realize that.
And maybe their feet are on this surface.
Yeah, exactly. And then the floor that we're looking at through the opening is the floor we're looking at right there in that picture. Okay.
Okay, maybe.
So maybe I could have done it. So that would be okay. So then if I do establish that they are in that hexagonal tube, I can use the humans and the Navi avatar people standing in that tube to get the size of the tube. Once I have the size of the tube, then I can get the radius of the circle. And then I can use the video with the timer to get the time that one rotation happens.
Mm-hmm.
And then from there, I can use acceleration equals v squared over r to get the g's.
Yeah.
So I could have done it. Okay.
Oh well.
Oh
Okay,
well.
yeah. Okay,
But,
conceptual solution. Hey,
yeah.
the
Yeah,
best
yeah,
type
there
of
we go.
physics is conceptual physics. Just understand the
Yeah.
idea.
Yeah. Would have been cool to see if those spins are realistic. And since it's a James Cameron movie, I'm going to expect
Probably.
that
Yeah.
those spins are probably going to be like 0.8 g, I would guess. To
Yeah,
me,
he's
the
very detailed.
radius of those things also looks quite small. I would want bigger circles so that
Uh huh.
you don't have so much difference in acceleration from head to toe.
True.
Because it's kind of small. But
I don't know. I mean, these are the ships from Avatar 1, and those things were big.
oh,
Yeah, I don't know. I don't know. I don't know how to scale this.
Yeah, but those are pretty big, and compared,
Right.
those ships are huge, and then those cargo containers are similar size, even bigger maybe by volume. So
Yep.
maybe these are actually maybe it's hard to get a scale because it looks small relative to the overall size of the engines and everything, but actually this thing is enormous.
Engines might just be enormous.
Yeah.
Mhm.
Okay.
Okay.
Didn't do the calculation. Oh well. But I bet
But you
it's
understand
realistic.
how to.
Yeah.
Honestly, when I graded exams, if you did everything except the actual calculation, you like set up all the equations, that's like 96 points.
It is. It's like 9 out of
98
10.
points. That's fine. That's fine.
Yeah.